Hi everyone. Unit 2, Limits, Subsection 2, the limit of a function. Part 1, the limit at a continuous part of a function. Okay, so within calculus we use the concept of a limit. Okay, a limit is simply the value of a function as we approach a certain value of x. They're typically written like this. Okay, let's try and expand that in a bit, just kind of blurs, but whatever. Okay, so it's written like the limit as x approaches a, so that little arrow thing is x approaches a, okay, of f of x. Okay, what it means, well, that's a little more fun. Okay, let's consider this function. It looks kind of crazy. F of x equals x minus 3 over x squared minus 4x minus 3. Okay, so let's make some use of some Unit 1 stuff, and let's make a quick sketch of this graph. Okay, so this is a rational function, so we always factor the bottom. So let's see, we go x minus 3 over, okay, factors of 3 is that subtract a 4, so that's x minus 1 and x minus 3. Okay, so when we do that, hey, look what happens with the bottom, so those cancel. Okay, remember though, there's still, we'll get there. So there's a 1 here. Okay, so really this simplifies to 1 over x minus 1. Okay, so remember that's the swoopy graph. Okay, that's just been, that has just been moved over right 1. Okay, so there's an asymptote at x equals 1. Okay, good. And so that's this, that's not good. Okay, so that goes like this, and then down, okay, and then this, and like that. Okay, and now remember, there's also wherever that part canceled, so there's not an asymptote anymore, but there is a point of discontinuity. Okay, and that's going to be at positive 3, so 1, 2, 3. So we have a open circle there, so the graph doesn't exist there. Okay, so that's what we've got going on here. All right, so now let's get back to limits. If I say, what is the limit of this function as x approaches 2? Okay, so we write that like this. So the limit as x approaches 2, again with that arrow, and x minus 3, or we'll just write the function again. Okay, so all we really have to do is evaluate this function at x equals 2, or find f of 2. All right, so the limit as x approaches 2, okay, of the function. So then we just, see I did the math for us here, yay. Okay, so we put in the 2's here wherever there was an x. We get negative 1 over negative 1, which is 1. Okay, if we look on the graph, and I'll write in red for us, okay, so if we look on the graph at x equals 2, okay, y, that's pretty close to where 1 should be, so it kind of makes sense. So from our graph, we can see that this function is continuous at 2, right? There's no holes or no asymptotes right around that red line up here. See, look up here, right here, guys, right there. Okay, well, really right there, but still. Okay, that means that the function carries on at 2. There's no holes, there's no asymptotes at x equals 2. All right, so generally, if a function is continuous, so it goes on, no holes, no asymptotes, the limit as x approaches a of our function is simply f of a. So you just evaluate the function wherever you need to. Okay, all polynomials are continuous. Okay, right? The polynomials, they go like that, and they go on forever. Okay, that kind of thing. There's no holes. Okay, so as the limit as x approaches a of any polynomial is just p of a. For rational functions, so rational functions are the polynomial fractions, so whatever. Okay, they're the same thing. You just evaluate the functions at a, whatever that number is, and this will work as long as q of a doesn't equal 0. That's to mean that it's defined, that q of a, this part here, right, because you're never allowed to divide by 0. Okay, well, let's see where this goes. So examples. So given the function 2x plus 3, sketch the function and then determine the limit as x approaches 4. Okay, fair enough. Okay, so 2x plus 3, okay, that's a y-intercept of 3, 2x, kind of, whoa, that was bad. Okay, kind of like that. That's a quick sketch. Okay, and then as x approaches 4, 1, 2, 3, 4. Okay, so that would be up here somewhere. Is there an asymptote or a hole right there? Well, of course not, because 2x plus 3, the domain is everything. So all we have to do is we just evaluate at x equals 4. So we say the limit as x approaches 4 of 2x plus 3 equals, well, 2 times 4 plus 3. So that equals 11. Okay, so if we look on the graph, if we were to draw this, draw it out, not sketch it out, this point would be at 4, 11. As x approaches 4, y approaches 11. Okay, easy enough. Now we look at something a little trickier. Okay, find the limit of this, then draw a sketch of the function. Okay, so again, let's have a quick look at what this does. Let's factor the bottom, minus 5. So again, x minus 5, x plus 1. Okay, so this part cancels. So you get 1 over x plus 1. Okay, we have a point of discontinuity at x equals 5. Point of discontinuity, a pod, at x equals 5. And we have an asymptote at x equals negative 1. So look, if I'm evaluating at 2, this graph is continuous at 2 because it's not one of these things over here. So all we got to do then is substitute in. Okay, so this is just going to be the limit as x approaches 2 of x minus 5 over squared minus 4x minus 5 is just going to be, okay, well, 2 minus 5 over 2 squared minus 4 times 2 minus 5. So that's negative 3. Okay, 2 squared is 4. 4, and then 4 times 2 is 8, so 4 minus 8 is negative 4. Minus 5 is negative 9, so that is going to be 1/3. Interesting. Okay, and then it says draw a sketch, so I guess we should draw a sketch. Funny how that works. Okay, now again, we did the work already, so that's what we're sketching. Okay, so there's an asymptote at minus 1. Okay, this is that swoop graph again. So it looks kind of like this. And then like this. Okay, and then at x equals 5, there is a point of discontinuity. So there's a hole there. Okay, so that's what this graph looks like. When x approaches 2, so let's see, that's going to be 1, 2-ish. Because that hole is supposed to be at 5. So at 2, does it make sense that that y value would be close to 1/3? Well, that's what it is. So anyways, the limit as x approaches 2 is 1/3. Awesome. Okay, number 3. So limit as x approaches 2 of this. Okay, looking at this really quickly. There are factors of 7 that add to 3. There are no factors of 7 that add to 3. So this guy, this particular graph, has no chance of being 0 when x equals 2. So this will be continuous at 2. Okay, so we just substitute in. So 2 minus 4 over 2 squared minus 3 times 2 plus 7. So that's minus 2. Okay, 2 squared is 4, minus 6 is negative 2, plus 4 is positive 2. So this is just negative 1. Okay, so again with the whole idea of the limit, as x approaches 2, y approaches negative 1. Okay, in this case we can even go one step further and say that when x is 2, y is 1. That's interesting, but that's not going to happen for much longer. Okay, and the last example for this part, okay, find the limit as x approaches 3 of 4. Well, wait a second. 4 is a constant function. There is no x. So if we have a quick sketch, and this is longer than it needs to be, but the function 4, 2, 3, 4, is just a horizontal line at y equals 4. So as x approaches 3, 1, 2, 3, y is still 4. So on a constant function, and when there is no x's, the limit is just whatever the function is. All right. Thanks, guys.